Hello everyone, this is Mohammed Shoaib and I'm gonna give you a brief overview of Windows threads. So to understand Windows threads, we have to firstly understand these following topics. What is a process, process structure, process creation, different types of process, what are advantages and disadvantages of process, then what are threads, uses of threads, difference between threads and a process, and what is meant by multi-threading. Moving on, we have what is a process. Process is nothing but a program in execution. It is also called as a task or a job. A process is a program in execution which states that I can give you an example for this. Here we have Google Chrome. These all are processes 1, 2, 3, 4, 5, 6, 7, 7 processes of Google Chrome, in the sense that 7 tabs of Google Chrome are running simultaneously. This is an example of process in a single program. And several processes share the computer simultaneously, which indicates that it uses the memory simultaneously. Moving on, we have the process structure. When a program is loaded into the memory and it becomes a process, it can be divided into 4 sections. These are the 4 sections: stack, heap, data, and text. The stack indicates the process which contains temporary data such as method, function, parameters, return address, and local variables. Heap is nothing but dynamically locating to a process during its runtime. Text is nothing but current activity represented by the value of the program counter, and the data represents the global and static variables. Global variables are nothing but which are defined outside the function, and static variables are nothing but which are defined inside the function and which keep the memory throughout the program execution. Next up, we have the process creation. So how exactly a process is created? Created as tree of processes, resource sharing, execution. The init process inherits process whose parents have terminated. Coming to created as tree of process. Tree of process indicates a parent and a child process. A child process inherits all the properties of the parent process. The resource sharing, in the sense all, some, or nothing. All the processes, some of the processes, or none of the processes. Execution. Parent and child execute simultaneously. Parents wait for child to terminate, then the parent terminates prior to child process, which continues to execute. And lastly, we have the init process inherits process whose parents have been terminated. Coming to different kinds of process, we have the starting state, then we have the ready state, then we have running state, and the block state. In the starting state, the process starts, then it comes to ready state where it is waiting to be assigned a process by a processor. Then it is assigned a process by the operating system. It might be interrupted by the CPU scheduler to assign to some other process. If process P1 is busy with a task, then a given task is given to a process P2, and process P3 is in waiting state until process P2 completes its execution. Then we have the running state. Once process is assigned, the process is set to run and the processor executes its instruction. In the waiting state, it moves to waiting state while waiting for a file to become available. If P1 is executing a particular task, then P2 is in waiting state until P1 completes its task. Then the last stage is termination. Next up, we have the advantages and disadvantages of process. Operating system normally protects process from one another. They provide each computation with its own virtual machine, allowing the computations to be independent. The processes can run on different machines, unlike threads that have to run on the same machine. Since process can run on different machines, the operating system takes care of its security. And the biggest disadvantage of process is that it is expensive and it takes up a lot of memory. What are threads and why to use them? Coming to threads, a thread can be defined as a semi-process that has its own thread ID. Thread ID is used to uniquely identify a thread. Stack, which is used for memory purpose, and program counter, which is used to point to a particular location and executes a given piece of code. The other definition is thread is a lightweight process and is a basic unit of CPU utilization that is under the control of a process. So why do we use threads? A process with multiple threads make a great server. For example, printer server. Printer server is nothing but a multiple users can access a single printer at a given instance. Because threads share common data, they do not need and use inter-process communications. Threads are dependent on one another. We can say this by the parent and the child relationship. Because of the very nature, threads can take advantage of multiprocessors. Advantages and disadvantages of threads. Coming to advantages, they are cheaper to create in resource. Threads allow parallel programming. The threads can be executed parallelly, and context switching is much faster when compared to processes. Coming to disadvantages, since they are dependent on each other, if one thread is corrupted, then the whole threading gets affected, and the operating system does not protect one thread from another thread like it does for processes. Each process is protected separately, but in the case of threads, it does not support that format. All the threads have to run on the same machine, while in the processes it can run on the different machines. Next, we have the processes versus threads. Similarities: like processes, threads share CPU and only one thread active running at a time. Each thread runs at a particular time. Like process, threads within a threads within a process execute sequentially. Threads execute sequentially. Like processes, threads can create children, and like processes, if one thread is blocked, another thread can run. Differences: unlike processes, threads are not independent of one another. Unlike processes, all threads can access every address in the task. Threads are assigned to assist one another. They are dependent on each other, and in the case of process, they are different users, but in threading, it is a task of a single system. Next up, we have advantages and disadvantages of threads over multiple process. Advantages: threads are very inexpensive and inexpensive to create and destroy. They are inexpensive to represent. And coming to sharing, threads allow sharing of a lot of resources that cannot be shared in a process. Coming to disadvantages, the major disadvantage is that the kernel is single threaded, and security breaches. Since there is an extensive sharing among threads, there is potential problem of security. Next up, we have the multi-threading. Multi-threading is nothing but executing multiple tasks at a given instance of time. There are three models: many-to-many, many-to-one, and one-to-one. In many-to-many, we have the user space and kernel space. The kernel thread is nothing but it is slower to create, slower, and it is slower in the sense of creation and managing it. In the user level thread, it is generic and can run on any operating system. In many-to-many, we have 6 processes which are connected to 6 threads. and the developers can create as many as threads as possible when run in parallel on a multiprocessor machine. This provides best accuracy when the system is blocked. In many to one, we have 6 threads, but many threads are connected to one single thread. When thread makes a system call, the whole process will be blocked. In many to one is used when the system does not support user level threads which is executed by the operating system. Only one thread can access at a time. In one to one, this process is more concurrent than many to one. It supports multiple threads to execute in parallel on microprocessors. In one to one, one thread is connected to one user thread is connected to one kernel thread.